Hello wonderful person, this is Anton, and in today's video we're going to discuss the top 5 closest stars to our own sun using the data from 2016. Now, the reason why we're using the data from 2016 is because in the last few years we actually found some new stars that are not even listed in this database in Universal Square, but are actually real stars that we've discovered using new techniques. We are not going to be talking about more common stars like Sirius, Altair, or Procyon, because these stars are a little bit farther away and we'll talk about them in one of the future videos. But for now, let's discuss the 5 closest stars that you may have not actually known about. Welcome to What the Math. And we're actually going to be using Space Engine to do this because I find that Space Engine has slightly more good-looking objects compared to Universal Square. And here we can actually take a look at all of these stars that I'm going to mention, and possibly even their planets that might have been procedurally generated. And anyway, so back in 2012, there was actually an article on space.com that sort of summarized the closest and the nearest stars with their designation and with a lot of other parameters, just so you could actually see what is basically close to our sun and what we've discovered so far, and of course what we've seen so far using various telescopes. But the thing is, since then we've discovered new techniques that allowed us to see a lot more by increasing essentially the magnification, where you can see much dimmer objects that are closer to us. And this is sort of what we were able to see. We were able to see a lot more stars, not only far away from us, but also in our vicinity. And so let me just decrease this a little bit, and we're going to go back to our sun, just so you can actually see that there's quite a lot of relatively dim stars around us as well. And some of these stars are brown dwarfs that are very difficult to see. Now, the closest star to us hasn't actually changed in quite a long time and will not change for at least 1 billion more years. And that's, of course, the star we're going to right now, Proxima Centauri. Now, it's technically, or possibly, part of another system known as Alpha Centauri, but some scientists think that maybe Proxima Centauri is actually its own separate object. We're going to approach to it, and you'll see that it actually has quite a lot of procedurally generated objects next to it, including a planet that may actually have life on it, and I've talked about this planet previously in one of the previous videos, and this really beautiful asteroid that is actually technically a comet. Now, one thing we know for sure about Proxima Centauri is that it's a star that actually hosts one of the most Earth-like objects close to us. And so we might be very likely one day exploring the system and trying to land on the planet now known as Proxima Centauri b. But not so far away from Proxima Centauri is, of course, Alpha Centauri, and you'll see how close it is once I move away from here. There it is. This is Alpha Centauri, and Alpha Centauri has 2 stars. We thought there were actually planets around it, but now we think that maybe the planet we thought was there is actually just an artifact from essentially bad instrument adjustment. So it was not real, it was very likely to be just an error in calculation. There might still be some kind of a planet somewhere here, but we just haven't found it yet. And the 2 possibilities, 2 potential planets are around Alpha Centauri b, which is this smaller, slightly darker star that is orbiting in this really interesting pattern with Alpha Centauri A. So these 3 stars are technically today considered to be one single star system. So it's known as Alpha Centauri system, and this is the closest system to us. Now, this one you may be familiar with, and obviously we're going to go to the next one that you may have heard of before as well, and this is a star called Barnard Star. It's actually a relatively well-known star that was discovered quite a long time ago. It's only approximately 6 light years away from Earth, whereas Alpha Centauri was about 4.2 light years away from Earth. And this particular star is known as a red dwarf, or in this case, red subdwarf. It's a class M4 subdwarf. So it's not very bright. It's not actually very exciting, but for many years, scientists have actually been trying to discover if this particular star actually has planets around it. And there have been a lot of speculations. There was even a speculation that it had a lot of gas giants orbiting around it. This was back in the 70s, but in the last few years, we kind of discredited most of these findings, and we think that maybe there is no large planets around it, but there might be some terrestrial planets which would be very difficult to discover because of the way that this star is positioned and the way that these planets orbit around it. So it would be kind of difficult to discover, but one day we might find out. This star was also a destination for the so-called Daedalus mission. Back in the 60s, scientists actually came up with this plan to launch kind of a nuclear-based or nuclear bomb-based craft, which would actually be able to reach this planet in about 40 years by using nuclear bombs that would accelerate it to about 12% of the speed of light, and then it would slow down and try to essentially approach the star and possibly land on one of the planets. Now, this mission was scrapped a long time ago, mostly because, well, first of all, we actually banned the nuclear tests in the atmosphere, so that was kind of a very big setback for this type of project. And second of all is that we didn't have the technology to actually create something like this back then. We only had a lot of nuclear bombs, but not the actual craft. Now, that's one of the planets around Barnard Star. This is procedurally generated. We don't actually know if it exists, but because this is a warm ice giant, it's very likely that it might not actually be real. And looking back at the star, I have a few more things to mention about it, and one of them is that the reason it's called Barnard Star is because it's named after the famous American astronomer E.E. Barnard, who actually was able to calculate its proper motion in the sky. Even though this star was originally discovered back in 1888, so over 130 years ago, he was the first to officially calculate how it moves and its proper motion in 1916, which is actually exactly 100 years ago from now. So technically, it is kind of a special occasion and I guess a kind of a birthday or anniversary for this particular star. Which is why we're actually going to talk more about it in one of the next videos. Let's go to the next star, and this is when things get a little bit more interesting. A few years ago, the third closest star to us was actually Wolf 359, but it has moved to the fifth location now because we've discovered two more objects between Wolf 359 and our own sun. One of these objects is known as Loman 16, which is right here. This is actually a binary system as well, and it has not one but two brown dwarfs orbiting in a very interesting way. So here is their orbit. One is on the inside, one is on the outside, and we're going to go check out one of them. These two brown dwarfs were discovered very, very recently. I believe it was actually in 2013, and we suspect that there might even be a planet around one of them. We don't really know if it's there just yet, but we suspect there might be a planet due to the variation in their orbits of these two stars. So this is Loman 16A, and let me show you Loman 16B. And even though in Space Engine there is actually no planets around these two brown dwarfs, we think that there might be a planet around this one called Loman 16B. So that's the third closest star system to us, and as you can kind of imagine, this is already actually not one, not two, but 5 different stars. So there's Alpha Centauri A and B, Proxima Centauri, there is Barnard Star, and then there's 2 stars here, but we consider these to be one star system, so this technically counts as one. The next on the list is known as WISE 08550714. If you want to find it in Space Engine, you actually have to type its full designation, which is WISE J0855, and that's it right here. 85510.83. So it's a very funny sounding designation because we actually just recently discovered this in 2014, and the reason why it's a star worth talking about is that because it's actually a so-called subdwarf. It's actually one of the dimmest, one of the coldest stars you can imagine. It's a star that's just barely a star. It's essentially what's known as a sub-brown dwarf Y class. Very, very, very cold, very, very, very dark, and this is kind of what it looks like in Space Engine. You can see how it's basically this terrifying looking subdwarf, which is actually a star. And the reason why we know that this is there is because of this WISE analysis that was actually... And even though some people might not even think that this is a star, but instead think that this is some sort of a gas giant that is just very, very large, much larger than Jupiter, this technically does classify as a star because today we actually consider brown dwarfs to be star-like objects as well, and they have their own classification, and because it might even host some sort of a planetary system around it. So all of these are procedurally generated, and they're going to be very, very dark, so you won't be able to see the surface, but they might be there. And so we think that this is actually the fourth closest star to our solar system. So this is a star known as Y0855107144. Doesn't have a name yet, and you will definitely not be able to see this in the night sky because it's so dark and so cold, but in Space Engine it appears as a tiny red dot right there. And as soon as you move away from it, it's going to be gone forever. And the last number 5 star is what used to be number 3. This is the infamous Wolf 359. And the reason I'm saying infamous is because it's a star that appeared in so many different science fiction TV shows, movies, and so on and so forth. The reason why it's kind of popular is because it used to be one of the first stars that was discovered to be a red dwarf that's so close to our planet Earth. And because it was so close, we always were fascinated with the idea of colonizing it, possibly living on in this particular star system. And many science fiction movies, including Star Trek, use this system for many different events, including a very, very big battle in Star Trek between, I believe, the Federation and the Borg Collective. This was from one of the Next Generation episodes of Star Trek, where Jean-Luc Picard loses the battle and becomes assimilated with the Borg. Now, we're not going to talk about Star Trek, obviously, but we're going to talk about this star very briefly. So first of all, this star was actually discovered back in 1919, so something like 97 years ago from when I'm making this video. And what we know about it is that it's actually a so-called flare star. It's a star that has a tendency to flare up and release a lot of energy once in a while. And flare stars are not particularly hospitable to life, because once in a while it releases so much energy that it might actually completely strip these planets of any kind of life that might have formed on it. Now, that's just a suggestion that we have today. We haven't really studied flare stars thoroughly enough yet. But we think that, if there is life somewhere in this solar system, the system of Wolf 359, it might only be on planets that have quite strong magnetic fields that would be able to protect those planetary surfaces, and of course any possible life on those surfaces, from these really, really massive, really energetic sun flares that would very likely destroy life. But despite being a flare star, in other words, a star that has these occasional hiccups and releases a lot of energy, this star is not actually very large. As a matter of fact, it's only about 9% of the mass of our sun, and is just on the limit of what we even consider to be a true star. In other words, this red dwarf has just enough mass to actually start its own nuclear reaction, which brown dwarfs that I showed you before don't have. And this is essentially a much smaller, a much less massive, but a lot more active star in comparison to our own sun. As a matter of fact, it's only about 60% of the radius of our own sun. Like I said, 9% of the mass, but it's a lot more active in terms of actual solar flares, and would probably have quite a lot of activity on its surface as well in comparison to our very, very quiet, very mild sun. And actually, as I mentioned before, sun is one of the more quieter stars out there. And this would be one of the more wild, one of the crazier ones. And this is the 5th star from our own sun at a distance of approximately 7.8 light years away. And that right there is our own sun. This is what our sun would look like from this distance. So let's go back to our solar system, and hopefully you learned something from this video. Now you know what the new 5 closest stars to our sun are as of 2016. Now, this might change again if we discover more brown dwarfs in the vicinity of our sun, or if we discover something else that we haven't seen before. But for now, this is essentially the closest object to our beautiful sun. Anyway, thank you for watching. Please subscribe if you still haven't. Share this video with someone who you think might enjoy learning from video games and want to learn more about science, math, and space sciences as well. I'll see you in the next video. Game you later, and as always, bye-bye.